Hello everyone and welcome to another video. This one's gonna be kind of two topics, but they're pretty similar, so I think it should be alright. It's gonna be on concentration and dilution, which go together. So that makes sense. Okay. So let's start with what is concentration of a solution? I always think there should be an S in this word. There's not an S. Concentration is the amount of solute in a solution. So basically, how much salt did we get into our salt water? There's a lot of different ways you can describe concentration, but we are only going to talk about molarity this year for simplicity's sake. So what is molarity? You probably guessed it has something to do with moles. I don't know. Okay, molarity equals moles of solute over liters of solution. So this liters is total. I should do this one. Total liters of your whole thing. So yes, that's it. That's the equation. You can abbreviate it. M equals mole over liter. So let's do an example. Woo, so exciting. Okay, so find the molarity if you have 11.5 grams NaOH per 1.50 liters. So first we need moles. So we are going to convert. Oops, I wrote that wrong. That's okay. 11.5 grams. Woo. I think we all know how to do this by now. If you don't, I'm very sorry. Over a mole. And so that's just going to give us. So, as you can see, I didn't round to sig figs. You're going to want to use the unrounded answer your calculator gives you. On the paper, you can round to sig figs just to keep track when you're showing your work. So I could say like 8. But you want to use that number that's in your calculator. And then you're just going to say this. And since we're already in liters, we're just going to do this over this. Don't forget units, obviously, blah, blah, blah. And that gets us 0.192. So that would be the molarity of sodium hydroxide. So how you write that is you write the number. Oops, I don't think it's this way. Or it might be that way. I forgot how to write it. Okay, I think you write dash M sodium hydroxide. That's what I've written down, so that's what we're going with. Either that or the dash goes after the M, but I can't remember at the moment. Yeah. Oh no, that's right. This is how you write it, because it's the molarity of that. This is correct. And yeah, that's basically it for concentration. Oh, wait. Okay, say you're asked to find the concentration of ions in a solution. And this will be asked, there's owls about this. So say it wants the concentration. What is the concentration of each ion for a solution when you have 75.61 grams of magnesium chloride? Oops, that's not how that works. Oops. Okay, magnesium chloride, and it's dissolved in 25 milliliters of water. So you don't have to write the equation for these, like the balanced equation, where it breaks into its ions, but it might be helpful, just to see how many ions you would have. So this is a solid. And then when it breaks, it would become aqueous, because now they're dissolved in water. So it has 2 plus charge. There's 2 of these. So that's just basics. So now what you have to do is first get the number of moles. I think we all know how to convert, so I'm just going to write it out. So that's how many moles of the whole thing, but we're not looking for the molarity of magnesium chloride, we're looking for the molarity of ions, but we have to do this first. So moles over, and then make sure you put your liter. It was milliliters, so now we want it in liters. So that gives us 3.177 moles magnesium chloride. But that's not the answer it wants. It wants what is the molarity for the ions. So then you're just going to multiply by how many ions there, well, not exactly, but like, yeah, how many ions there are. So for magnesium, we know there's only one, so it's just, that is the molarity of magnesium ion. And then for the chloride ion, you're going to multiply this by 2 to get 6.353. That would be the molarity of your chloride ions, because there's 2. So you're just, when you have one where it wants the ions, you need to multiply by the number of ions you would have in the balanced equation. So that's concentration. So now this is dilution. So what dilution is? It is the preparation of a desired solution by adding water to a concentration. Your moles of solute remain the same because you're not adding more, you're just adding water. So this is how, say you have a really strong acid and you want it to be less strong, you can dilute it, add some water to make it have less. So since the moles are the same, the equation is going to be molarity times your first volume, your second volume, equals the molarity of the second one over the volume of the second one. And that just comes from when you're solving for moles, it's molarity times liters. But since the moles are the same, you could just set them equal to each other. So that's where this comes from. And your 1 is normally gonna be the your 1 is normally gonna be the more concentrated solute. So let's do an example. So we're solving for the volume, and we have 15.8 molarity of HNO3, and how much volume is required to make 250 milliliters of a 6 molar solution. So we have our M1, this would be our V2, and then this is our M2 because these go together. So we're solving for V1. That's what we don't know. So just like with all the gas problems, you want to probably work it out algebraically. First, we're solving for V1. So V1 equals M2 V2 over M1. And now you can just plug all the numbers in. And since we're solving for volume, you don't need to convert to liters. You can if you want, but you don't need to unless it's specifically asked. So you just plug it in. Volume equals 6 times 250 over 15.8, and that will get you 95 milliliters. So yeah, how you distill things is you put it in this giant glass jar thingy, and then you put some water in, then you put your thing in, and then you fill it up for water. I don't really know if you need to know that, but that's kind of how it works. That was a really bad explanation of it, but that's how it works. So yeah, that is concentration in dilution. So pretty simple equations and stuff. Yeah, let me know if you have any questions. Thank you so much.